Before I show you this next formula, I want to remind you what an exterior angle is. So we talked a lot about them with triangles, so I'm going to draw you a triangle. If this is an interior angle right there in the triangle, an exterior angle is going to form a linear pair with it. So we learned that back in our triangle unit. So you've got an interior angle and an exterior angle on the outside, and they have to form a linear pair. So the formula that I teach my students is the exterior angle sum. Okay, so again, this worksheet came from another teacher, so they're giving the formula for the regular ones. I don't really get into that. We can find it problem solving. The only thing we need to memorize is this exterior angle sum. Now the good news is this time it's not a formula, it's actually just a number. So we don't have to calculate it. For every single polygon, the exterior angle outside angle sum, when I add them all together, the total is 360. So how can we see questions, how can they ask us questions about this theorem? What's the sum of the exterior angles of a hexagon? So, you know, I'm the type of person that likes pictures, and maybe I'm thinking about this hexagon, that vocabulary right there, but what I really need to pinpoint is, what is the question asking me for? Exterior angles. Okay, so right away hopefully my brain is thinking 360. That's my exterior angle sum. So then I say, what do they want me to do with that? Wait a minute, they are asking me for the sum. Wait, the sum of the exterior angles of all polygons is 360. They're trying to trick me here. My answer is 360 degrees. It does not matter if this said hexagon, octagon, dodecagon, the answer is going to be 360 if they're asking for the sum. Alright, let's look at another example. Find the measure of one exterior angle of a regular 12gon. That's another way of just saying, because you know sometimes we say n-gon for polygon, unknown number of sides, so they're just telling us that the number of sides here is 12. Okay, so which angle? Oh yeah, exterior. Okay, I should be thinking 360. Okay, what do they want me to do with that? Oh, they just want me to find one this time. Now, if every angle is the same, I could divide to find just one. So is this regular? Yes, it is. Regular means they're all the same, and that means I can use division to find my answer. So 360 is the sum no matter what, and I have 12 sides, so that means I have 12 angles, so I'm going to divide that 360 degrees into 12 groups and see what each one equals. Okay, so each one's going to measure 30 degrees. Okay, read it again. Did I answer this? The measure of one, that's just one exterior angle. Yep, I like my answer. That makes sense. Okay, so let's see, I feel like I want to do a couple more. Oh, this is a good one. Okay, a regular polygon has an exterior angle that measures 45 degrees. So I don't know how many. Poly just means many. So I've got some kind of polygon over here at the side that I don't know what that looks like. It's hiding off here. But what I do know is that the exterior angles, so remember interior and exterior angle is 45 degrees. Okay, so all my exterior angles are 45 degrees. I know they're all because of the word regular, so every single one of these is going to be 45 degrees. Alright, so how many sides? Well, what we know every time about exterior angles, if those are always adding up to 360, this concept is going to be the same as the number 2, because division is going to break this into equal groups. Because it's regular, I know that the total is 360. Each one of these is going to be 45. So again, I'm taking my total, I'm dividing it into the measure of each angle, and that's going to tell me how many groups I have. Okay, so if I have 8 groups, that means I have 8 angles, and if I have 8 angles, I have 8 sides. You know, this is multiple choice. It could have used vocabulary there. That's an octagon. The direction said how many sides, so it should just give a number. Okay, let's see, what else? This is a really great one because I want to go back to a problem number 9. Let's do this before we do that. One extra angle of a regular polygon measures 36. What does one interior angle measure? So students tend to struggle with this when I give it on assessments, and it's very straightforward, just asking if you know the definition. It's giving you an exterior angle. It is regular, meaning they're all the same. So the exterior angle is going to measure 36 degrees. And it wants us to find one interior angle. So the exterior was 36, what's the interior measure? Alright, well, exterior angle, interior angle, go back to the definition. The definition of an interior and exterior angle is that they make a linear pair. So if they gave me the exterior angle and they want the interior angle, I'm literally just using the definition to find it. I'm taking my 180 and I'm subtracting 36 because they make a linear pair. 144. Okay, so I wanted to go over that one more time, that concept one more time before we go back to page 9. So I want you to actually go back to page 9 to one that we skipped. Okay, let's go to number 3. So number 3 says how many sides in the regular polygon, below. Okay, so this is a way that they've asked it before in standardized testing, where they have kind of a rectangular figure, something hiding a polygon behind it. Okay, so I don't know how many sides this has, but that's what they're asking me, but I know that I have an interior angle. So, you know, when I go to problem solving, I'm thinking interior angles right now. That's where I'm going to go every time, because that's what this is right here. This is an interior angle. Okay, but then I have a problem, because how many sides, that's what in is. In represents how many sides. So I'm kind of, you know, at a dead end here. So there's an algebraic way to do this, but it's kind of messy. So what did we just talk about on page 10 here, that problem we did number 5? Well, we talked about the fact that an interior and exterior angle are going to form a linear pair every time. Interior and exterior angle form a linear pair. I don't really want to talk about number 5, because look at that. It's not coincidence. Okay, so that's how I'm going to do this problem. I don't want to mess with interior angles, so I'm going to extend this side here so that I can use my linear pair to find that exterior angle. So I'm going to do my linear pair, 180 minus 144, and I'm going to get 36. So now what I know is that every single exterior angle is 36. So how many sides is it going to have? Well, if every single exterior angle, so now I'm dealing with exterior angle sum, and that's 360. So if I know the sum is 360, I'm going to use division. 360 divided by 36 gives me 10. So if there's 10 groups of exterior angles that measure 36, that means there's 10 angles. And if there's 10 angles, then there's going to be 10 sides. So the question has said how many sides. So that's what it is. And again, if that's vocabulary, that's a decagon. Okay. Let's look at one other type of problem before you go practice all this stuff. Okay, page 11. Page 11, number 8. So sometimes we have these expressions here where we know we're going to be looking for an equation. So I look at these angles and I'm asking, what is it? This is an exterior, this is an exterior. Oh, that is not an exterior, but this is. So I'm seeing that 3 of these are exterior angles. And I see that I can very easily use my linear pair here because I have the interior angle is 60. So I'm going to go ahead and subtract from 180. I'm going to subtract 60 from 180 to get my exterior angle. Now, problem solving here, my strategy, I'm looking at what I have here and I realize that at this point I have an exterior angle at each vertex. I'm going to get rid of that interior angle because I don't want to accidentally use that. What do I know about the exterior angle sum? I know that they always add up to 360 degrees. So I'm going to take my extra angles, 4x, 2x minus 10, 120, and 70, and I'm going to total those to be what I know to be the extra angle sum for every shape, even this quadrilateral. Alright, now I'm going to combine like terms. All this stuff's on the left side, so 4, 6x, negative 20, negative 10, 120, 70. I can use my calculator if I'm not confident. Negative 10 plus 120 plus 70. Okay, I'm going to use negative if I do that out front. 180. Okay, now that I'm moving to the other side of the equal sign, I'm going to use my inverse operations here. Okay, 6x equals 180, and then I'm going to divide by 3. I'm sorry, divide by 6 to get 3. Divide by 6, divide by 6. Okay, so the direction just asked me to solve for x, so technically I am done, but this is very easy to check. If you're my student, you know I'm always on you about that. It doesn't take much time when you have a calculator. 4 times, good thing I checked, 4 times 30. That's going to make a little more sense. 120. That's 120. That was 70. Now I just need this one. 2 times 30 minus 10. That's 50. And now I'm going to take my 4 exterior angles and just double check that they actually add up to 360. Make sure my algebra is right. 120, 50, another 120, and a 70. Yep, they all add up to 360, so I like my solution.